Hello everybody! In the previous video I started an overview of my pet project and observed the general structure of auto tests created using the NodeJS platform with the Mocha test framework. In this video I'd like to tell you about the test in more detail. Before I begin to explain the test, I should talk about how to control the device and how to obtain information from the device. Let's go to the Blynk platform and look at some details. On the devices page, we can see the list of all devices. In tests, we use this page for switching to some device. The test we'll be analyzing today uses two devices, named BoolyaBoxer 1 and Jumble Switcher 2. Let's move to BoolyaBoxer 1. We can see the name of the device and its status, online or offline. We check the status at the beginning of the test. On the dashboard tab, we can use the Activate Detection switcher, which defines the device mode and sets the luminosity threshold. And of course, we can grab any information from this page using XPath. Let's move to the Data Streams tab. Here you can see a table with a list of data streams. Each data stream is connected to a specific pin and has its own value. The name points to the corresponding dashboard control. For example, if the Activate Detection value is 0, then the dashboard Activate Detection switcher is off. If we turn the switcher on, then its data stream value becomes 1. So, turning the switcher and changing its data stream value work the same. We can set the required value and get the actual value using a certain URL. Let's switch the Activate Detection mode is on. Go to Update Value URL and on a new page we set 1. In this URL we can see the device token and pin. We will use these values in the test. Let's back to the data stream page. Here we see the value is 1, and if we move on the dashboard, we can see the Activate Detection switcher is on. So let's go to the test. I will open it in Visual Studio Code. I'd like to explain one test line by line using test meteor data. In this test, we get actual meteor data like luminosity, temperature, and humidity, and then compare them with the test asserts. Let's start. The first line of the code imports the chai library. The second line creates an alias for the chai assert module. After these lines, you can use the assert object to make assertion in your tests. Further, we use the require function to import the module located at the path into our script. So the code within that module is executed and any exports from the module are made available for use in the script. Here we declare the variables common actions and meteorboxer actions. They refer to the common actions and meteorboxer actions modules accordingly. Whatever functions, objects, or values are exported from this file be accessible through these variables. Next, we use the asynchronous function before. Inside this function, the code instructs the browser to navigate to the specified URL. We use a wait keyword to ensure that the browser has finished opening the corresponding page before moving on to the next line of code. After the wait UI pause that we've declared in main object module, go to login. As you see, we call it by common actions variable that refers to common actions module. We can go to its code by Ctrl+click, and as you can see, it finds the element go to web console, clicks on it, then finds email and password by XPath and fills the specified fields with values from the Blynk properties file. Next, the before each function is executed. Inside this function, we use setDataStreamValue2 function, which is located in the Common Actions module. If we go to this function, we will see the following. The function using driver opens the URL with the specified device token, data stream ID, and a new value that we have declared as an input parameter for this function. Let's go back to the test and look at how we determine the device config and data stream ID for the specific device. We have double switcher config, double switcher template, device under testing config, device under testing template. They are determined in the Boolean test meteo data module. Let's see the devices module. From this module, we get device token and data stream ID for our devices. Thus, when executing the before each function, firstly, we set value 1 for both double switcher sockets, which means the light is off and the motion activator is off. We set 1 because data streams for this device have a reverse value. 1 means off. Next, we set the value 0 for BoxerBoxer 1, which means the activate detection mode is off because data streams for this device have a direct value. Now let's go to the test. Firstly, we assert that BoxerBoxer 1 is online. Let's have a look at this function. We switch to the defined device, find the status by XPath, and check if the status equals online. The next line of code is data processing pause, which equals 7 seconds and has been declared in main object module. This is the time to update the data on the device microcontroller and set this data to the Blynk platform. Next, we have switchLightOn function. As you see, we call it using MeteoBoxerActions variable that refers to MeteoBoxerActions module. When we move to this function, we can see that it uses setDataStreamValue2 function that we looked at earlier. The switch to device function returns us to the BoxerBoxer1. Look at this function. If we are already on the needed device, then we do nothing. Otherwise, go to the device page, search for the needed device by XPath, and go to the dashboard of this device. Next, we obtain the current luminosity data. Let's go to the function and see that we get data from DS general data stream and assign it to a general data variable. This data looks like this. So, to get the luminosity value, we split general data using the colon as a delimiter and get the second element of the array produced by the split method. And then, using parseInt function to parse a string and convert it to an integer. Let's get back to the test. Next, we get the current luminosity threshold value from DS luminosity threshold data stream. This line of code asserts that the luminosity should be greater than current luminosity threshold. If this condition is not met, an error message will be issued with the specified message. Next, we obtain the current temperature data. We get data from DS meteo data stream and assign it to a meteo data variable. This data looks like this. Then we get the temperature value using the same functions as for luminosity. This line of code asserts that the temperature should be between 20 and 30 degrees. We use the AND operator to combine two conditions. It checks if the temperature is greater than or equal to 20 and less than or equal to 30. If this combined condition is true, the assertion passes, otherwise it fails. Next, we obtain the current humidity data using the same approach. The next line of code asserts that the humidity should be between 15 and 60%. After the test is completed, the after each function is executed. The code inside this function returns the device to its original settings. And finally, the after function is executed. This code closes the browser in which the test is run. Let's run this test and see the result. A new browser instance is opened. Logging into the account. Switching to Boolean Boxer 1. Checking the online status. See luminosity is 0. Turning the light on. Returning to Boolean Boxer 1. You can see the luminosity has been updated. Getting data from data streams. And finally, closing the browser. According to the test logs, all functions before each, after each, and after are executed successfully. The obtained data for luminosity, temperature, and humidity correspond to the test asserts. Thank you for your time.